everybody. My name is Mark McIntyre. I'm a Chief Security Advisor here at Microsoft in our Security Solutions area. Really looking forward to the opportunity to talk to you today about tomorrow's maritime security operations. I'm really pleased to be joined with an old partner in crime of mine, Joe DiPietro. Joe, do you want to introduce yourself and your background?
Thanks, Mark, and thanks for having us. My name is Joe DiPietro, and I was formerly the VP of Customer Success with CyberX, who was recently acquired by Microsoft, and I was thrilled to be able to participate in the show today.
Great. Well, we certainly wish we could have been there in person or at least live, but hopefully next year we can certainly make that happen. In the meantime, you can see our email addresses right here. So please, this is a short presentation trying to cover a lot of really interesting, compelling, and dynamic content. And so if you have any questions, comments, if you want to follow up, please do not hesitate to contact us. We'd definitely love to follow up and talk with you. We're going to cover today the topic of maritime cybersecurity. We want to look at the futures, what we see going on in this ecosystem. So here's a look at the agenda. You can see we'll talk about some challenges and trends, partnerships, modern security operations, the way that we see investments going, the way that Microsoft is positioning our ecosystem to help you address tomorrow's security and business needs. And we also want to make sure that you see and have access to important reference architecture attack framework information. Okay, great. So just quickly, just to level set, these are the numbers. So these are the trends that we are seeing. It's important to note that actually these trends, the dollar amounts, the rates you're seeing, these are actually pre-pandemic. And so what's important to note about this is that these trends were already occurring, prior to the pandemic. If anything, the pandemic has essentially accelerated these trends, and we fully expect to see more and more, probably even like a steeper curve throughout the next, many years. So we're seeing a real need for collaboration, for more flexible collaboration. Obviously, security, money lost to crime is a huge issue. That's why we're all here. We see an explosion, really, of the mobility and the device landscape, and we'll talk quite a bit about that. Of course, there's more and more use of machine learning and AI type tools. This will be, these are literally areas of where national governments are getting involved, setting strategies, making big investments, and ultimately data. How you position yourself, the investments you make from a business perspective, a mission perspective, and yes, from a security perspective, ultimately are going to come down to how well you can collect and analyze and take action in real time on your data. And for one more, level set, this is a look into the attack landscape. All right, and so the point here is to emphasize that if you are from an organization, a government, contractor, consumer group, educational institution, what have you, if you don't think that your people, that your systems, that your data is particularly sensitive, if you don't think it would be naturally attractive to a threat actor, this slide is meant to respectfully disabuse you of that notion. The fact is the attack landscape is very dynamic. It's actually very much a service-driven economy, sort of pure capitalism. And so really the costs of attacks are so low that the incentive is always there for attackers to go after us, to go after all of us, whether we're consumers, business, government, military, what have you. And so just please think about this landscape when you consider how attractive you might be to an attacker. Just quickly, at Microsoft, we do invest heavily in security. We are committed to protecting our ecosystem, our customers, our partners, certainly our governments, national security agencies, And so we invest heavily in cybersecurity. You can see some numbers here. And of course, we also make significant investments in terms of how we position our data centers around the world, and the commitments that we make around protecting privacy. Okay, so I mentioned earlier data, and so we have learned a lot over the last many years about the importance of data, in this case, security data. So what you're seeing here in this slide is, it's a summary, a point-in-time summary of essentially Microsoft's, let's say, security, big data security ecosystem. Some of you may know this as as Interflow. Some of you may know it as the Intelligent Security Graph. Microsoft does not sell data. We do not sell threat data. Right? We manage data, ourselves and through partners around the world. We manage it on our behalf of our customers in a shared responsibility model. But it's incumbent on us to do more, to put this data to action, to really help it, to use this data to help us protect our customers and our ecosystem. And so this is just a sense of the various resources that we have from running, many of the world's leading, online services. So one example would be Section 52. Joe, do you want to describe what that means?
Yeah, thanks, Mark. And Section 52 is specifically targeted at doing research, threat research for IoT and OT, operational technology components. A fantastic team, and they recently discovered many different CVEs, if you will, or 0 days on some IoT devices. And these IoT devices will range in the millions. And part of what's happening is they discovered a vulnerability where it's called bad ALEC. So when you create IoT devices, you use memory management, and you can overflow the buffer within the memory management. But the root cause, or the summary of this, is that there are a lot of IoT devices that we need to make sure we put in compensating controls as a result of this investigation.
The point here is that we use and we have access to, we manage a lot of data on behalf of our customers around the world, and we want to put that to use to help collectivize and automate the security defense ecosystem. Because if we can work together, and we can then defeat the attackers. One way that we do this is through partnerships. You can see here the Microsoft Intelligent Security Association, sort of an A to Z look at a variety of global security partners, and we collaborate, we partner, we want to help organizations that are providing important security services. Want to help them deliver a more secure service to you. And so, from Microsoft's perspective, we believe through our investment strategy in security that we can certainly protect more and more of your Microsoft and non-Microsoft systems. But of course, you have partnerships, you have large investments in different companies around the ecosystem. So we want to make sure that we are working responsibly with the Defender ecosystem so that they can also deliver secure services to you as well. Working together, we can all help defeat the adversaries. So one area, particularly around maritime security, that we see as increasingly critical is going to be the convergence of devices, traditional IT, Internet of Things, operational technology devices. These are, I think the differences here are going to really merge in a way, or I guess they're going to disappear. And so, Joe's going to talk a little bit now about how we view the Internet of Things and the operational technology attack surface in the ecosystem.
Thanks, Mark. And this is a quote from Gartner, but the growth rate in IoT devices is going to far exceed that of other connected devices. So in 2020, they're talking about 7.3 billion units, and it depends on the research group that you're referring to. In contrast, what they mentioned is IoT, which will have a much faster rate, and the population is about 26 billion units at that time. So what this does is it increases your attack surface. So you now need to be more concerned about IoT devices as a threat vector for somebody to compromise in order to get into your environment, or if they build different components on the ship to be able to secure and control those aspects.
This becomes more and more important when you think about, you think about the future of maritime operations, naval operations, for example, and you have the U.S. Navy, and I'm sure other navies thinking about autonomous, vehicles, forward deployed, autonomous, literally, a new fleet or platform capabilities that will be built around OT, operational technology. And so if you think about the sea lanes, for example, you think about the explosion of data, tomorrow's marketplace is going to look more and more like, you're going to see more and more, let's say, digital commerce, and therefore potentials for conflict in these, traditional sea lanes and, in and around tomorrow's markets. And more of our ability to work together to protect tomorrow's economy will depend on how well we can secure these types of devices.
Yeah, Mark, great point. And these, Gartner refers to these as cyber physical systems, or CPS, right? And the more information is going to be digitized, and the more Internet of Things gets connected so that people can be much more efficient. If we look here, Industry 1.0 was way back in the 17th century. 2.0, where you have the mass production lines, assembly lines, and electricity. 3.0 of industry, where we have computers and some level of automation and robotics. And we're at the stage of Industry 4.0, where we have cyber physical systems, Internet of Things, cloud computing, cognitive computing, AI, and a whole wealth of other aspects. So the rise of Industry 4.0 introduces a whole new range of security issues that you can see, and especially from the operational technology, the OT components. And you can see here from a robotic automation to simulation or digital twins, all of the system integration components that are needed in order to make these systems work together in a much more efficient manner. You look at cyber security, cloud computing, additive manufacturing, right, where you're doing predictive maintenance on different components so that you can swap out that part before it fails. And augmented reality and big data, as Mark mentioned before. So Industry 4.0 definitely has created a number of different challenges. And the other aspect of Industry 4.0 is longer lifetimes present new challenges. When we think of the lifetime of an IT device, it may be a few years. But if we look at the OT devices that are out there, especially in power, utilities, things like that, ships, they're lasting for decades. And so we need to be able to design industrial Internet of Things, as well as Internet of Things, to have a long lifetime so that we can span this full life cycle. And the other aspect to be concerned about is many of these devices, they're not like you can walk down to the data center and go swap out a part. They may be out at a sea, in shipping lane. They could be on oil rigs. They could be any places within the supply chain, far away from some of the support technicians that are needed to be available. So as we talk about this, let's take a framework of an OT, operational technology, security reference architecture. And we'll break this up into two components. The first component is the IT environment. And everybody's familiar with IT security, with confidentiality, integrity, and availability. And this is where you have warranty lengths of 3 to 5 years. You'll swap out equipment. The protocols are very well known. They're all web-based, REST APIs. In the security hygiene, you'll use multi-factor authentication. You'll patch systems. You do some threat monitoring and some anomaly detection and so forth. In the OT environment, the number one concern is safety. And then after safety, you have your availability and integrity. And as we mentioned before, the hardware age is in many years that you need to be concerned about this. But the protocols are a lot different. They're very proprietary and industry specific, like Siemens S7 or Rockwell with Ethernet IP or Goose and so forth. And the security hygiene is where you can use isolation as opposed to patching at a frequent basis. You rarely patch because you can't afford to take down the operational components. So as we go through this operational technology, you can see that there's a term called the Purdue model. In the OT world, this will tell us what is responsible for the manufacturing environments in order to run a ship or a SCADA system on a ship. You have your supervisory control monitoring the different components there. And then you have your process and your physical machinery down at level 0. From here, you have business analytics sensors to tell you what is going on inside of the OT world to make sure that the ship is running efficiently and so forth. But the command and control may be in the IT environment, right? So this is where the business analytics and the applications reside, and you're able to get the data from the OT environment into the IT environment. Over here, we're using zero trust principles. You know, in the case of data centers, you have segmentation that you're going to align with your network, your identity access, and so forth. And then you're going to have user access control, where you dynamically grant access based on explicit principles, right? And you're going to monitor the user and device level risks before you grant them access to the network. And as you see up here, we're starting to see a blending of attacks. And this is where the convergence between IT and OT are. And with an IoT reference architecture, in some cases, we have digital transformation drivers so that the OT environment is connected up into the cloud, where you may do business analytics like Azure, IoT Hub, Power BI, things like that. But these are so that you can monitor and get business efficiencies. And then you have to deal with regulatory and compliance. And there's a lot of emerging standards like the CMCC, Cybersecurity Maturity Model. So this will give you an overall framework. And then when we want to secure some of these environments, if this was like a nuclear power plant, for example, you'd have a very hard boundary of isolations, right? And here you would have a disconnect between the IT and the OT network. In some other cases, as business processes allow, you have a little bit more of a softer boundary. And this is where we might put in a network tap, for example, to monitor the equipment that's in the OT environment. This is where you can have a sensor, you can have a plant that does the security controls, and you can also have a global monitor within the IT environment that manages the overall scheme for the enterprise. And this is where you can optionally have cloud-connected components as well, going up into Azure Sentinel and having other security analytics. But this gives you an overall reference architecture for the security components. And then as we look at Industry 4.0, they break it down into a similar type fashion, where you have device level information. This is where the equipment and automation and performance data is, where you have your robots and motors and drives. At the control level, this is where you have a PLC, a programmable logic controller, a manufacturing cell, if you're building ships, for example, assembly lines and so forth. Over here, you're having a multi-plant performance coordination. This is for global operations for all of your factory and production. And then at your ERP level, you can see part of the enterprise partners that we work with at this stage. Next, it's really important, as we mentioned, to align both the IT components and the OT components. And this is really critical for operational success. The different groups need to work together in order to provide successful integration and visibility. And understanding the political boundaries are key to success. What we're seeing in the industry is that the CISO and part of the information security group down here is responsible not only for the IT, but also for the OT. And when we look at the OT, or the operational environment, the plant engineer, the general manager, the line of business, they need to coordinate together in order to secure the entire environment. And this is where the operational technology network, the industrial Internet of Things, the industrial control systems, ICS, or SCADA would really be starting to converge. So very briefly, within IT, as we look at how attack frameworks are set up, MITRE is a great attack framework, and they've released the Enterprise Matrix. And this is mainly responsible for the IT network. And if we look at our Purdue model, which is a connectivity model, right, that's layered on top of the network, and you need to also layer the security elements on top of the Purdue model. But the enterprise network is at levels 4 and 5. Over here. And then you have your integration in with your industrial DMZ at levels 3 and 3.5. MITRE recently announced the attack framework for industrial control systems last year. And so there's a separate framework to handle all of the OT components, like the sensor, the actuator, the PLC, programmable logic controller, the historian, engineering workstation, and HMI, human machine interface, and so forth. So with this, I'd like to transition it back to Mark to talk a little bit about some zero trust and how we can get the entire environment secure.
Great, thanks a lot. So Joe pointed out something really important that I think is often overlooked, which is that how you build and support let's say, a device strategy or an IT security strategy or an OT security strategy. These are not meant to be one-offs or separate from the larger, business strategy. If you think about the convergence of devices, you think about explosion of data out there, your security planning surely needs to be integrated into an equal partner to your larger business planning. Think about it, security data, critically important, but it is data. It's one more data set, that you use to evaluate, to analyze, to make incremental, hopefully substantial, but at least incremental improvements in a strategy. And your ability to parse that out and to make certain improvements in how you conduct your operations, your security operations, in conjunction with, making improvements in your business operations, your sales and marketing, whatever, that will help you be more successful. So security should not be separate from larger business planning. So zero trust has been a really, really hot topic the last couple of years, certainly here in the U.S. government, for example, the Defense Department. And so it's been around for several years, but thematically, it's simple and elegant, let's say. Anytime your people or an identity or a device that has an identity assigned to it, anytime a identity or device, we could call it a subject as well, anytime they want to use or access an object, a piece of data, some infrastructure, an application, what have you, there should be a policy around that. And zero trust really means that you essentially assume, you assume compromise, assume breach. It does not by any mean that you give up. It just means that you have a practical assumption that something has already been compromised, and then plan from there. You verify explicitly, and you employ least privilege. One of the really interesting opportunities here as we think about building tomorrow's maritime physical systems is that you can build essentially net new security ecosystems. So Microsoft, for example, has what's called Azure Sphere, which is it's a hardened Linux kernel to build operational technology devices. So you can literally, it's open source. You can take it for no cost, take the SDK, you can build net new devices, and you can connect them to your existing security operational infrastructure, or of course in conjunction you can do it in parallel. And so it's a great way to start building from the ground up this tomorrow's device security ecosystem. Zero trust is built in the sense that you can create these controls, these role-based access controls. You can use a lot of really compelling data around the behavior, the expectations of a certain device, a certain credential, let's say, and you can set a policy that works for you. And then you can essentially have real-time policy enforcement to gate authentication attempts, to gate access attempts to resources. And so it's a really flexible way, especially in a modern and in tomorrow's collaboration environment where we're talking about systems that could be hundreds of kilometers away. We're talking about people, systems that are no longer working behind a traditional physical perimeter on a base, for example, or on a ship. People are going to be people and devices. Assets are going to be forward deployed, are going to be moving. And so Zero Trust is a great security model that we think anticipates the future of collaboration. You can see ample number of examples around certainly the U.S. government around how they're already starting to deploy Zero Trust. I think we'll see more and more move in this direction. So along those lines, we also have, and Joe will build out this architecture slide for security operations. So how does it come together? How do you build these devices? How do you build this new ecosystem? How do you run your businesses, your missions in a way that is both modern, but also, secure and responsible or responsive towards your expanding device ecosystem? This slide is meant to convey, that can be helpful to you. It's how Microsoft does it. This is more or less a reference architecture for how Microsoft conducts our global internal security operations. We get that question quite a bit. Microsoft, you are a global organization. You have a lot of people, partners. Your technologies are embedded around the world. How do you conduct your security operations at scale? How do you keep pace? How do you understand what's going on around the ecosystem? We built the slide as a way to help convey that. And so if this slide can be of value to you in part or in full, then that's great. And we certainly can help you if you want to dig deeper into some of these areas. This is another look at it. We do our best in this presentation to avoid specific product references. We want to make sure this is thematic, but this is a way just to be practical as to how we do it ourselves internally and how you can take advantage of this already. Essentially, we have XDR capabilities using that big data security graph I talked about earlier, using analytics. You can see the various properties, the various businesses, components of your organization to include your IoT, industrial IoT and OT ecosystem. And ultimately, we want it to be able to do security operations at scale, cloud first, taking advantage of cloud power, elasticity, and such to help you and your partners conduct your security operations, literally in real time. Think about it also. Security resources are scarce, they're expensive. It's hard to train security people. And so, so do you want your security personnel, your security partners and teams, do you want them managing infrastructure, or do you want them looking at the events, really going after the events and the alerting that really matter to you? So automation is key. Let machines, let cloud do a lot of that real, the bulk of that work for you, that real tier one work. Free up your security people, your partners, to focus on, on the more important areas of your security estate. So Joe is going to talk about, I'm going to show you a demo actually as to how it comes together in our remaining 5 minutes or so. He's going to walk through. Give you a picture being 1,000 words, a look into what tomorrow's modern security operations environment looks like.
Super, Mark. Thank you. Super, thanks, Mark. And what we'll go over today is a little bit of a demo between Defender for IoT, as well as how we can integrate in the alerts into Azure Sentinel. You can see over here that Sentinel has workflow and owners associated with it. In this particular case, we have owners like Kim Wall, for example, events and alert, but we also, more importantly, have all of the different MITRE attacks framework: initial access, credential, discovery, execution, impact. So these are the different tactics within the MITRE system, or the MITRE attack framework, that is propagated up into Sentinel. And what you're seeing right here is this is a device map. And so what we can do with Defender for IoT is automatically discover all of the devices within your OT environment and build in a model so that when you click on it, you know who specifically these devices have been communicating with. So for example, if I'm looking at Ethernet IP, this is mainly Rockwell devices. You can see that these are the PLCs that are associated with Rockwell type system. And we can get down into granular detail, even of the backplane and what slot and communication these devices are, and build also a network map of the devices as well. Okay, and this happens to be a communication adapter. So auto discovery, because you can't secure what you can't see, right? That's a really important part of it. The next element of what we can do is look at different alerts within the network and understand if there's any bad traffic within the environment. So we have a number of different alerts that can be associated with any one of these components. And let me load a couple of more results here. Okay, unauthorized name query. So if I double click on this, this tells me that this particular laptop was accessing another device that was not responsible to be on the network. And we can even download related PCAPs of this environment as well. From here, we can do a quick risk assessment of the environment where we can download the specific files. Let me open the file, and this will give you an overall site score. So here's your security score of all the devices. I have 55 devices that are vulnerable, 22 need improvement, and it gives you a highlight of all of the different vendors that are involved in this environment, along with the security score that's associated with them. And then lastly, sometimes what you want to do is try to figure out if somebody was to try to compromise your environment, how would they go about doing it? And this is what we call an attack vector simulation. So in this particular case, and I've seen traffic where the attacker is open to the internet. They're getting access to my historian that has a known CVE associated with that. From there, I can get to my engineering workstation through a known CVE and then compromise my programmable logic controller that's handling some critical piece of equipment. So at a very high level, this is what Defender for IoT can help you secure within the environment. All right, and it also folds all the entities up into Azure Sentinel. So Mark, why don't you wrap it up for us?
Sure thing. So we're trying to show and convey what converged security operations at scale globally in a very dynamic environment can look like, where the meaning of traditional devices is really is becoming obscured. At the same time, we still have to find hidden meaning from these devices, these very same devices that provide business value, that help you run your business or run critical infrastructure, also have important security data that we also need to understand literally in real time. And so when we're facing an evolving, some would say even a worsening threat environment, along with a talent shortage in security, it's incumbent on us in the industry to work together to bring together cloud-powered tools like these that are intuitive and that provide context and that provide your security teams and your business leadership with literally instantaneous findings. So to learn more, you can see some resources here. And like I said, Joe and I would be more than happy to follow up along with our colleagues in the region if you want to dive deeper into any of these areas. So thank you very much for your time. Really appreciate it. And we look forward to be able to hopefully meet with you. Thank you very much.